friends, this is Meera and welcome back to my channel. Today we will discuss how to find centroid of area of a small bridge. In this video, I am going to give you a very quick procedure to solve complex numerical of centroid. So keep watching till the end. You can go through my video on basic concepts of center of gravity and centroid for better understanding of concepts before we start solving numerical. You can find video in iCard or a link in the description box below. So let's begin. Suppose we want to find out centroid of area of this small pedestrian bridge passing over a canal. We are interested in front view of bridge, so here it is. We will assume that all lines are straight and all angles are perfect and will neglect the slight curvature of bridge. Okay, now let's have a look at the given dimensions. So here are all dimensions we know. Let's find out centroid. First of all, we will divide the whole area into more basic shapes whose centroid locations are known to us. Centroid of some shapes are given in reference books like triangle, rectangle, semicircle, quarter circle, etc. You can directly memorize this and use in numerical. So let's have a look at some of the options we have to divide the whole area into smaller parts. First option is to divide the whole area into triangles and rectangles like this, and then fifth part, that is semicircle, will be deducted from the whole area. Second option is to divide whole area into rectangles and then subtract triangles and semicircle. Apart from this, you can divide the area into any shapes as per your convenience. It gives same result. Let's say we will divide the whole area like this so that number of divisions will be minimum. First part is a rectangle, second part is a trapezoid, and third part semicircle will be subtracted. Next step is to locate the reference axis and find out all missing dimensions. Here, the tip to solve numerical very quickly is to check if the given object is symmetric about both or at least any one of the axes. Let's check it out. If we place x-axis at the center of bridge and rotate half a part of bridge about x-axis, you will observe that both parts are not similar in shape or dimension. Thus, our bridge is not symmetric about x-axis. So place x-axis at the bottommost plane of bridge. But if we place y-axis at center and rotate half a part about y-axis instead, both parts overlap. All the angles and dimensions, everything is same on both sides. Therefore, our bridge is symmetric about y-axis. So take y-axis at middle point so that the opposite x coordinate will be 0 and just find out y coordinate for all parts. Now check for any missing dimensions of all parts. For rectangle, width is equals to summation of horizontal dimensions, that is 17 meter plus 2 meter plus 2 meter equals to 21 meter. Height of rectangle 3 meter is given. For trapezoid, width of longer side is 17 meter and shorter side is 8 meter. Only height h is missing, which is total height 7 meter minus height of rectangle 3 meter equals to 4 meter. For semicircle, diameter is given, that is 8 meter. So radius of semicircle will be diameter 8 divided by 2 equals to 4 meter. Next one is an important step where all required data will be calculated. Before we start calculations, let me quickly remind you the equations to find out x and y coordinate of centroid. X coordinate is equals to sigma AIXI divided by total area, and y coordinate is equals to sigma AIYI divided by total area. So to find out centroid, we will have to find out area, x and y coordinate of all individual divisions denoted by I. In our case, there are three divisions, one trapezoid, one rectangle and one half circle. So in general, these are equations to find out area, x and y coordinate of a trapezoid. Remember, A is the shorter side of trapezoid, B is the longer side and h is height. For symmetric trapezoid, equation to find x coordinate is more simple, so you don't worry about the scary looking x coordinate here. Area of a rectangle is width multiplied by depth and centroid coordinates are b by 2 and d by 2 depending on position of rectangle, and area of semicircle is pi r square by 2, x coordinate r and y coordinate is 4r by 3 pi. Here all dimensions are in meter, so unit of area will be meter square and unit of x and y coordinates will be meter. Now let's find it out for rectangle 1. Right now we will just focus on first division, rectangle, and ignore other two parts. Locate centroid and dimensions of rectangle. Now area of rectangle is 21 meter width multiplied by 3 meter height, that is 63 meter square. The most important step is to find out x and y coordinates of all individual shapes. If you know how to find it correctly, problem of centroid is very easy to solve. So now, as we have placed y-axis at center, opposite coordinate, that is x coordinate will be 0. And y coordinate is height divided by 2, which means dimension in y direction, that is 3 divided by 2 is equals to 1.5 meter. Now check out the location of reference axis with respect to the selected rectangle. As per reference figure, x-axis should touch the lowermost plane of rectangle. Here in our case, x-axis is at same location. So final area and coordinates will be same as previously calculated data and no alterations needed. We will repeat step number 3 for trapezoid. So first we will highlight trapezoid and locate centroid and dimensions. Now area of a trapezoid is A plus B by 2 into h. Here the shorter side A is equals to 8 meter, longer side B is equals to 17 and height h is equals to 4 meter. Put all the values in equation and we get area A2 is equals to 50 meters square. X coordinate is 0 again. Equation to find out y coordinate is 2a plus b upon a plus b into h by 3. Put all values and we get y coordinate equals to 1.76 meter. But this method can be applied only if x-axis touch the lowermost plane of trapezoid. But it is not the case. Location of x-axis is some distance away from trapezoid, so some change in coordinates will be necessary. So to find out final y coordinate, we have to add this distance from x-axis to the previously found coordinates of shape. This distance is same as width of rectangle, that is 3 meter. Now area is same final x coordinate x2 is 0 and y coordinate y2 will be 1.76 meter plus 3 meter equals to 4.76 meter. Now repeat step 3 for third part, that is semicircle. Highlight semicircle and locate centroid and dimensions. Now area of semicircle is pi r square by 2. Here r is 4 meter. So put value of r and we get area equals to 25.13 meter square. X coordinate is 0 for this division too. And equation to find out y coordinate is 4r by 3 pi. Put value of r and we get y coordinate equals to 1.7 meter. Again, this individual y coordinate of semicircle can be considered as final if x-axis is touching the lowermost plane of semicircle. In our case, x-axis is at exact same place. So, final coordinates will be same as previously calculated data and no alterations required. The last step is to sum up all the data we have just calculated. We just need to input area, x and y coordinates results in the equation of centroid of an area. So to find out x coordinate of centroid, we'll take moment of area with respect to y-axis. So total area moment will be equal to summation of moment of first and second division areas minus moment of third division. Negative sign is because bridge does not have that part. You can memorize this equation directly. Here all values x1, x2 and x3 are 0. So x coordinate will be 0. And y coordinate of centroid can be found out by taking moment of area with respect to x-axis. Put values of a1, a2, a3 and y1, y2, y3 in this equation. So y coordinate is equals to 3.3 meter.